Okay, Dragons, here's the review and their answers. I have it all worked out. I'm just going to comment on it. You can pause and write it down, study it, be ready for your test next time. A simple observation, we can see that the vertex is the ordered pair 0, -4. It's at the top of the parabola, so it's the maximum point. And the axis of symmetry is x equals 0. That's where it slices it in half. On the next problem, we want to put this in standard form. So what we're going to do, first of all, we're going to do our binomial x minus 2 squared. So we'll do the multiplication box and get the trinomial x squared minus 4x plus 4. We'll keep that in parentheses because we need to distribute a -3 to each of the 3 trinomial terms, and that gives me a -3x squared plus 12x minus 12. And the final step is to add on this 5. And -12 plus 5 is a -7, and that's in standard form. So that's your answer. So the next one of these, you can either look at vertex form and go through and find which one of them contains 6, 2. You notice that the first and the last one contain a vertex of 6, 2, so that this one does not. So we can eliminate this one as being our answer. So what we can do now is we can type this in our calculator, go to the table, and see if, we have the point 8, 18. And there it is right there. So the only one that fits the bill of the question is this one right here. All right, the next one, we're just going to do some observation. Zeros, does it cross the x-axis? It does not. We have the y-intercept as 0, -5 by simple observation. The vertex highest point is -1, -4, as is the axis of symmetry, x equals -1. We have our domain, all real numbers, and the range, all real numbers less than -4. And we find the equation by doing a calculator regression. Remember, we have to have 3 points. So what I did was I reflected the y-intercept to get this point. I have 3 distinct points. I do my calculator regression. I can do that real fast, I think. Again, just using these 3 points right here, I go to my stat button, type in -2, -1, and 0 for my x values, -5, -4, -5 for the y. It's stat, calc, and it's quadratic because of the picture. And we find out A, B, and C, and so I simply transfer that to standard form. A is -1, B is -2, C is -5. There's my answer. On this one right here, same thing. I don't know why we have 2 quadratics that don't have any roots, but hey, it is what it is. It does not cross the x-axis. I need to gather 3 points, so I pick these 3 right here. I could pick some other ones. So I have no zeros, no solutions. My y-intercept, I'm going to get back to that in just a second, how I got my y-intercept, because you can't, 18 is not on this picture, so I got to figure out another way of finding it. The vertex was 4, 2 by observation. Domain is all real numbers, and the range is all real numbers greater than or equal to 4. So if I do my regression, I come over here, C is your y-intercept. So I've got to find my equation first, and then I can come up here and answer the y-intercept. Right here, answering the question, we've got a Olympic diver standing right here, jumping up and making a splash down here. So the beginning height is your y-intercept, as it's always been. That's 24 feet because of the label on the y-axis. How long to reach the water? We're looking for the 0 because we're going to assume that this is the level of water down here. So it takes 4 seconds. What are the solutions? It's the same thing, 4 seconds in the y-intercept. So it's really just asking for the x and y-intercepts in these 4 questions. On problem number 6, it's a little different. We have our solutions. One of my solutions is x equals -3. So I need to set this equation equal to 0 by adding 3 to both sides. And I do the same thing over here. I need to set this equal to 0. So I'm going to multiply both sides by 8 to get this. And then I'm going to subtract 7 from both sides to get this. Now once I have both of these solutions set equal to 0, I'm simply going to transfer them back into the factored form of the problem, squish them together, put a f of x in front of it, and there's the equation. Once you have factored form, what you can do is you can use the box method to convert to standard form. That should be pretty easy. All right, on your test, you're going to have some bonus problems, and they're going to be of this variety. Give it a try. If you get it right, you'll get credit. If not, it won't count against you. Okay, so here are the answers to 7, 8, and 9. Take a look at it. Hey, it's going to be bonus. All right, this one right here, problem number 10, we just graph the points from the table right here, and we'll fill everything out. Time is independent, it's on the x-axis. Height is y. We should be able to answer that simply by looking at the headings on my xy table over here. Now, the domain, we're looking at a restricted domain between 0 and 6, so that's why we have x is between 0 and 6 inclusive. And we're also looking at a restricted range. So we're going to go from 0 to 36 for the y values. It is quadratic. We've got twin outputs. Remember, we have reflected points. And when we have that around a single vertex in a line of symmetry, guess what time it is? We have twin outputs, and it's a parabolic shape on the picture. Okay, so we can do a regression, pick any 3 points from the table above, do the regression like I did on the last one, and you could piece together the equation. How high was the football after 2 seconds? I don't know, let's go look. Here's 2 seconds, and we go up here, it's 32. We can also get that from our table as well. Pretty easy. When the football reached its highest point, again, you can look up here. There's the highest point, that's 3 seconds. Okay. How did you know that? Well, that's the vertex. It has no this point has no reflected y values, so that means it's the highest point. When did the football hit the ground? That is your 0. You're finding your x-intercept, so it would be 6 seconds. At what time was the football 20 feet high? It was 20 feet high 2 times. 20 feet going up at 1 second, and coming down, it was 20 feet at 5 seconds, and you can see that up here. At 1 second, it was 20, and it's going up. And at 5 seconds, it's at 20 feet on the way down.